So, how's it going? I cannot hear you. Yeah. So, we're going to talk about Docker for desktop. So, Docker for Mac, Docker for Windows. I'm working on those products in Paris. And I'd like to show you a long demonstration of how you can use this product every day on your project. So, instead of having a lot of slides, I've got only one slide. The rest is demonstrations. So I think I'll stop for the coffee gods and take quite a few coffee. Because a long demo is always interesting. OK? Let's switch to the demonstration. So I don't know if you noticed, but today we deployed a new website. And you can get started with Docker. And one of the ways to get started with Docker is to download either Docker for Mac or Docker for Windows. So just download Docker for Mac and install it on a machine where I don't have Docker already installed. OK, so maybe I've got it somewhere. Yeah, it should give you this DMG file. And as you've seen in the keynote, you just drag it into your application folder. And you just start it. You've got a couple of welcoming messages. The first time, it will ask you for your password so that it can install all the things, all the files you're going to need to run Docker, Docker Compose, even Docker Machine. And it will ask you if you want to migrate the existing Docker machine that you might have on your machine. So if you got one, you'll see this dialog, and I will migrate my data, because I used to work with machine, and I want to work with Docker for Mac now. You might have noticed that there's a small whale here, and a welcoming whale that explains that you're all set up. You've got Docker running on your machine. That's it. You don't have to do anything else. How cool is that? Yeah. Thank you. Thank you. So let's check that everything is working correctly. I should just be able to run Docker hello world. And that's it. It works. So this is really the idea that we had when we developed Docker for Mac and Docker for Windows. You should be able to install it and then forget about it, because it will be running on your machine, and you will have the CLI installed, all the tools you need in your day-to-day job. They are installed on your machine. You don't have to configure, like, you remember with Docker Machine Toolbox, you had to configure how was it called? The quick start shell. You had to export your environment variables. You had to install VirtualBox. Everything is fixed now. You don't have to do that anymore. It's really seamless, and you can just start working, because this is what you wanted to do in the first place. If you want to do some more advanced things, you still have a small preferences pane where you can select a couple of options. So you can ask Docker to start automatically when you log in. This is something that people asked us a lot with the Docker machine. They wanted to be able to have it started when the machine starts, which is obviously understandable. And of course, you have the ability to check for updates automatically, so that you can stay up to date with the latest version of Docker for Mac, and also with the latest version of Docker itself. Okay? So I won't play with these options today, just to show you. And I've got a couple of advanced options. Those options, you shouldn't really have to touch them a lot, but behind the scene, you still have a small VM that's working, that's running Docker. And sometimes you might want to increase the size of the VM, so the number of CPUs or the size of the memory. So sometimes you want to do that. You can do that. For example, I will switch to 8 gig, and I will just apply the settings, and Docker is restarting. And you might have to do it like once, because you know that you've got a machine with a lot of memory, and then you can just forget about it. It works. OK? So let me clean up a little bit what's on my screen. So I'm a developer. We are here to understand how Docker can help me as a developer. So I've got an application already cloned on my machine. It's a different application than the Votes application that you've seen at the keynote. It's not really the dogs and cats application, but it's very similar because it's a composition of different microservices. There's 3 microservices, or in fact, there's 4. And they are all described in a Docker Compose file. So maybe I can show you what I have. Who's familiar with Docker Compose? Oh, not everybody. OK, so in Docker Compose, you can describe your microservices. So I've got one microservices, which will be, I call the web. It's really the front end of my application. It's running Nginx. So it's an Nginx with static files, HTML, JavaScript, etc., images. So this will be the front end. And on the bottom, there is MongoDB. So there's a database that's running. And to make the 2 parts communicate and to add some application logic, I have 2 other microservices. The most important is the one called words-java. So it's a Java application, like a standard Java application that you might work on. This Java application will connect to the database and will serve a REST API to the front end. Something very usual, something you might all have in your projects. It's not something fancy. It's just that I managed to decompose the whole application into multiple microservices, and I can assemble them with a compose file, and then I can run it as a whole application, even if it's composed of multiple bricks. Each of those bricks is described in my sources. So I've got the description of the web, I've got the description of the words Java, and I've got a description of another component that I didn't talk about, which is a dispatcher. This one is written in Go. Let's go into the web folder just to understand what's going on here. So I've got static files, I told you. So it's really HTML, CSS, etc. And I've got, of course, a Docker Compose file. So Docker Compose describes this microservice. This microservice is based on Nginx, a given version of Nginx, and with additional configuration that is inside my web folder. So if I build an image from this folder, I will get my front end. If I do the same with the words dispatcher, this is a Go application. There's another Docker file. This one is based on Golang. It will expose a port on 8080, and it's basically a single Go file that composes this service. And same for the words Java. So this one is a little bit more complex. There's also a Docker file, a bit more complex because I've got OpenJDK, and I install a given version of Maven, and I've got a couple of options to how to run this part of my application and how to build it. OK? And it's a Java application, so you can expect like a src main Java sources with all the files, the kind of things that we kind of hate in Java. OK? So that's it. I described every service into one folder, and the MongoDB, which is the 4th microservice, is just a standard image that I pull from the hub. OK? How clear is that? So it was very easy to decompose my application into 4 services, and then it's also very easy to just start it. You've seen that at the keynote, sorry, and just Docker Compose up-d, and you've got it running. Let's try it. And let's discover what my application is. So my application is, this is something invented by poets in the 20s. It is something called the exquisite corpse. So the idea is what they did in the 20s, so they took a piece of paper, they wrote a word, and then they hide it, and they pass it to somebody else, and he wrote a word, and then at the end, you've got a random sentence composed of different words, and sometimes it's poetic, sometimes it's full nonsense, sometimes it makes sense. So I tried to develop it myself by storing some names in a database and having the Java code just look up adjectives, verbs, and names into the database, and then they are displayed here. The problem is it doesn't look very random, right? If I refresh, it's always the same sentence, and the sentence is not very interesting because it's always the same words. But let's forget the application for a second and take a look at that. I started a container on my Mac, and it is available on localhost. This is something that you were used to with Linux, right? But not with Docker Machine Toolbox. So the idea, we said it, and we are going to say it again, is to make it as seamless as possible for your developers. You start a container, they are available on localhost. You don't have to think about the IP address of the VM or whatever. It's transparent. This is where we develop some very complex things to make it very simple for you. OK, so let's take a look at my application. So I'm going to reduce that a little bit. As a developer, I might want to modify this application, right? I might want, for example, to add a title to the application. It's quite easy because if I take a look at the compose file, which is not, it's here. The web part, I've got what we call a volume. So I said that the directory web/static is mounted into the container at a given place where Nginx can read the files and serve them when I open Chrome. So I should be able to change those files and see them modified in my application. Let's try that. Let's open web static. The thing is, I'm a web developer, so I'm very used to modify the files and see it refresh automatically without me pressing the refresh button. For example, I've got this live reload button here that does exactly that. When I modify the sources, I should see the website updated in real time. Let's do that. Can we do it with Docker? Yes, we can. So I can really work on the CSS in real time and see the impact. So as usual, I don't even know I'm running Docker. I'm doing my usual workflow, and it's quick, and I've got feedback, and I can develop properly. And I think this is nice. What do you think? Yeah. So we should be able to add like a title. So I said I'm not sure I can write it exquisite, no. Exquisite corpse. It's a strange name. I'm not even sure it's compatible with the code of conduct. Live from DockerCon. Yep. Yeah. I'm not going to style it because, I mean, you're not here to learn CSS, right? It would be much longer than 40 minutes. One thing I might want to is to be able to debug my application, because it looks strange that I always have the same words displayed over and over. Maybe I can try to understand what's going on. So I've got my favorite IDE here. It's IntelliJ, and I'm going to like open the sources in IntelliJ. So it's a Java application. We're not there to really understand all the specifics, but there's some kind of web server that's running, which is serving a REST API /verb /adjective /noun. And maybe we could just set a breakpoint here in verb and try to understand what's going on. But to do that, this morning we showed you the short way. So we put the breakpoint and it worked. But you have to configure it, right? A little bit. So I'm going to show you how to configure it. So I've got this Docker Compose file. And I've got the description of the Java part. And in fact, I know that I should open a given port for my IDE to connect inside the container and debug the Java application. How do I know that? In fact, if I open IDE and I ask it to debug, I can create a new debug configuration on a remote process, and it will give me the command line, and it will tell me the port, so I don't really have to remember that. It's very useful to have this. So I created a debug configuration. I'm going to edit my compose file, and editing the compose file will not pick it automatically. I need to stop my application and start it. But what's nice is I don't have to stop the whole application. I can just stop one of the microservices and then restart it. And then it will be debuggable. Let's do that. So I've got multiple services running. I'm just going to delete to stop the words Java. Yeah, so obviously I've got one less container running. I will even remove it, and I will restart it. So now my application should still work. Where is it? It should still work, but I should be able to debug it inside my IDE. Let's try. So I've got breakpoint here, just debug, reload, and yes, I'm inside my IDE. How cool is that? So you can really, yeah, thank you. So you've seen it. It's not really magic, right? I mean, we've seen when we started with container, this is one of the first things that developers wanted. They wanted to be able to debug what's inside a container. And most of the technologies like Node.js, Java, .NET, they have a specific mechanism to be able to debug the code. And it also works inside a container if you open the ports that are needed. The thing is here, the little change that changes my life is when I created this configuration, I didn't have to look up the IP address of the container. It's not a VM for me. It's just running on localhost. It's the small changes that really help us every day in our day-to-day work. So I'm able to debug what's going on. And in fact, I don't want you to understand the code, but what it's doing, it's asking the verb, and the verb here is a supplier, and it's going to memorize. So in fact, just to explain what it's doing, it's going to query a word or a verb into the database. It's going to memorize it, and next time I request for a verb, it will send me this same word, same verb every time. And somebody told me in the team that, yes, we shouldn't touch it. This is the way it's supposed to do, because lookups in the database are very costly, so they want this part of the application, this microservice, to do only that. Query a word and serve it forever. OK. But what about my application? I would like to have really random, sorry. I don't want to do that. I would have to have really random sentences here. So what can I do? Do you have any idea what I could do? It's complicated. Sorry? Oh yes, I could have a container that dies as soon as this responds for a word and then start again. But I could have a little bit of downtime, right? What else can I do? Yeah. Swarm. I could create a swarm. What for? Oh, multiple containers. So what you're saying is I could scale this container, the WAS Java container, and I could scale it and make sure that I've got multiple versions that memorize multiple words, and then I will be able to have random sentences. So you said I should set up a swarm to do that, but in fact, I don't have to, right? I can do that as easily as typing docker compose scale, and I can scale a world. I can scale one of my services. So let's try scale 2. If I do that, I should have an issue. Let's try it. So there's an issue because of my port 5005. You know, I just debugged my service, and I set up a port that should be exported for me to connect into the container. And if I want to scale the same container multiple times, obviously, they cannot use the same port. So I need to change that. I need to revert that. So we cannot solve all the problems, right? Sometimes we still need to think. Yeah, sorry. So I'm gonna just stop my words Java just to make sure that I don't know if I should really do all that, but this way I'm sure that I'm start clean. The container is really clean. It's using the configuration I want it, and I can scale words Java. Yeah. So if I do Docker Compose PS, I can see my containers, and I can see that I've got 2 Java containers. So this is nice. I can do that on my machine without a swarm, without something complex. I'm just using the standard Docker features, and I can spawn multiple nodes of the same service. And let's see if I've got more random words. Oh, yes, a little bit. A shiny whale eats a shiny elephant. Yeah. A shiny whale will drink a pink whale. Yeah. Let's add some randomness. How many Java web server can I run on my machine? Well, 20. Let's try 20. Why not? Yeah? How do you like it? We should maybe vote. Yeah, it seems to like a lot the dead bodies, right? Yeah, OK. Let's keep this one. So that's cool because, you know, I didn't have to do complex things. Eventually, I'm going to deploy on a swarm. I'm going to deploy on the cloud. But locally on my machine, I can scale it, and it works. And it works very well. I can go up to like 50 Java nodes. Why not? So I can feel that some of the people in the room are just freaking out. What is he doing? Why is he starting 50 Java web servers on his machine? I can, so I try. Yeah. So what you can see is it's random, and you can really see the ID of the container that's responded to each of the requests. Okay? So I've got my random sentences. But how does it work, right? How is it possible that just by scaling a node, I was able to like load balance the different nodes? In fact, it's using one of the features that was introduced in Docker 1.10, I think, which is the round-robin DNS. So I'm doing something a little bit complicated with the round-robin. Usually, it just works, as you've seen in demonstration this morning. But what I did is I introduced another component in my application between the web and the words Java. And the web is just serving static pages, and it's just proxying the backend, the REST API. So I can ask for /word/verb, and I get a verb. But I introduced another microservice in the middle that is just a dispatcher that when it is asked for a word, a verb, an adjective, or a noun, it will just ask it to the service underneath. But instead of just asking to the service underneath, it will list all the IPs of all the containers that are running this service. It will pick one random address, just because I can do that. I tried. So we can take a look at the source code. It's very easy. It's written in Go. So actually, it's doing like a lookup on the host. The host is words Java. This name, words Java, was injected by the DNS server that's running on my Docker instance. So because I created a service called words-java, for my containers, there is a words-java machine somewhere on their network, which is nice. I can just hard-code this value in my sources, and at runtime, I can name one service or another, and this application will point to that service automatically. And it's doing a lookup on that host, and it gets the list of all the IP addresses for all the containers. So I got 50 now, so I should get the list of 50, and it chooses one at random. We can take a look at the logs to better understand what's going on. So Docker compose logs. So I'm just going to list the logs of all the microservices that compose my application. And in fact, when I refresh, I can see what's going on, or maybe. Here, there's one of the containers say, OK, I was asked for a noun, and I've got 50 available IPs, and I'm going to choose this one. And this is how I load balance between all the containers. And before 1.10, it was very difficult to do that. You had to use products that would listen to the Docker Engine events, register, and then would get all the IP addresses of these containers, would run a DNS server, and this is automatic. So as we said this morning at the keynote, we are trying to make those things that everybody wants to do very easy, very seamless, and here I just had to scale a microservice, and it's scaled. That's it. How cool is that? Yeah. I can hear that you want another sentence. Yeah, why not? So I developed my application, I debugged it, I didn't really change it, but it's running OK. I just need to scale it to make it interesting. What else can I do? So we've introduced new features in Docker 1.12, and one of the features that really interests me are services and application bundles. The idea is everything that I described into my compose file, I want to ship it in production. I want to be able to just say, OK, here's the description of the application, ship it with exactly those images, the one that I developed, and not something else. So this is what bundles are for. A bundle is a list of services, and those services introduced in Docker 1.12 are also interesting because they are persistent. If I create one of those services with the command line and I reboot my machine, when it reboots, it will start Docker for Mac. Docker for Mac will start, obviously, Docker daemon. And it will start my services, and the services will start the containers. So as soon as I've created a service, I can reboot my machine, and the service will be there. It's very easy for developers then to create a service for their Postgres database or Redis database. I hear a lot of developers saying, OK, every morning I need to start my containers to be sure that I can start my work. It's done. You just have to create a service for each of those containers, and when you start your machine, they will be started. Let's try to do that. So now it's the real beta features that I'm going to demonstrate, right? So to create a bundle, I need to start from my compose file that I'm going to edit a little bit. I'm going to remove that because this is not supported by bundles. OK, and I'm going to do a Docker compose bundle, and that's it. It's going to take all the images I was able to run locally. It's going to push them to the Docker Hub. It's going to make sure that it keeps the exact version of each of those containers. And then it will create a file in my local file system that describes all the services and pointing to each of those versions. You can see it wrote a bundle. I can maybe see what's going on inside that bundle. It's just JSON file pointing to very specific version of an image so that I'm actually sure that what I'm going to ship is what I developed on. OK? And this bundle, I should be able to run it in production. But why not run it on my machine first, right? I'm a developer. I should be able to try it. I managed to scale a container 50 times. I should be able to start a bundle too. So this will be the last demonstration. I'm going to stop everything that is running just to make sure. That's already 50 nodes. I don't want to add 50. I'm going to do a lot of cleanup. OK, so I've got a bundle, and I want to deploy it. To be able to deploy it on my machine, I need one more instruction. I need to activate the new Swarm mode in Docker 1.12. So I'm not going to talk about Swarm mode into details, but I'm just going to use it. I just do Swarm init, like you've seen in the keynote, Swarm init, and boom. I've got a single node swarm. That's really nice, yes? Single node swarm. And then I should be able to deploy my bundle. So this is where sometimes it's failed. I'll say, OK, coffee time. So it's loaded the bundle, and it's created services. Those services are persistent now. And I can query those services. I see them. So the demo gods were not really happy about my coffee drinking because they didn't really start the services. So let's wait for a second, or maybe we can just try to remove it. Sometimes it works. Oh, yes, it's starting. Yes, so I've got the whole stack started, defined as the new services API, and I should be able to see it on my machine. So you won't see a difference. It's just that now it's persistent services, and you should be able to see them. At least you should if I didn't have a bug, which is fixed in master, which is, I don't know why, it's published on port 30,000. Anyways, it's there. Yeah, I've got my application defined as services. Nice, isn't it? So I'm sure I can send this bundle in production. It will work. And one thing that I want to do before I do that, I just want to restart my machine, because why not? And I want to make sure that when it restarts, I've got Docker running, I've got my services running, I've got my containers running, and everything is there every morning when I come to the office. Hopefully the machine will reboot. We cannot fix all the problems, right? So Docker is running. The services are running. Hopefully the containers will start. Yeah! And I should have my application running. Thank you. Yeah, we should be thankful. OK, so that's all I wanted to demonstrate. So I've shown you how to install Docker for Mac, how to do live reload when you working on CSS, on web development. You are able to debug an application. It works with .NET, Java, Node. Any application that can be debugged outside a container can be inside a container. And I showed you how to scale it, how to transform it into a 1.12 bundle, to deploy it, and it works. So now it's time for questions. What should I do? Yeah. OK. Oh, yes, you should go to the mics. If you can stand up and go to the mics to ask your questions, it would be easier. Thank you.
So I just wanted to check the way to get from a Docker Compose to all of those things being defined as services to go through a bundle, or is there a shorter way?
A shorter way, you could write your bundle yourself, right? But usually when you develop, you are going to use Compose. This way you can really define into detail your application, and then it's one step to do a bundle, so it cannot be like shorter than one step.
Okay, just checking. Thanks.
Thank you.
Yeah, hi. The magic files that you just ran through and showed everybody, are they available in like a GitHub project or something for us to be able to take away?
You want the project, right? So the project is on my GitHub. It's called DockerCon 16. So yes, you've got the whole thing. You've got a README. It should work. You've got all the files. It worked on my machine, right?
Hi. So clarifying question and then a follow-up. So Docker, just to clarify what Docker for Mac is, it's running everything on a Linux guest OS inside a VM on the Mac, or it's running everything in Mac architecture?
No, it's really running a very small footprint VM. That's a Linux VM, and it's running on top of Xhive, which is the hypervisor that is based on the standard hypervisor on the Mac. And if you want to know more, you should like run to the session in the Black Belt room, because Justin is going to explain everything into details.
Great.
He's going to explain why it's so complicated to build something so simple.
Great. So then the follow-up is, so everything you showed is really cool. I'm just wondering, what's the build and test experience like? Do you have to delegate the build to the guest OS and synchronize files back and forth? And what is that experience like? And can you get IntelliJ to run the tests inside the container? Because getting it to connect to a remote VM is one thing, but a test.
Yeah. So you can do both, in fact. You can really develop outside of the container, or you can develop inside the container. Here, I do the build inside the container, and I could run the test inside the container. And I think on part 2, we're going to demonstrate how to run your test inside containers on the cloud, so that each time you've got a pull request, it runs test. So this one you should really check. But you can choose both. You can also do it like step by step. Let's say you've got your whole workflow outside of containers. You can start by 1 container, and then 2 containers, and then containerize everything.
Cool, thanks.
Thank you.
Actually, my question is pretty similar to that one. So if you change a line of code in the Java IntelliJ, how do you recompile and redeploy that, and then so that you see the new updated version on your test environment?
So
is that for session 2?
Yeah.
Okay.
No, this morning,
All right, cool.
This morning you saw that you could just change a line on a Node.js source, you save it, and boom, it's refreshed in production. In Java, it's a little bit more complicated, right? You cannot do that natively, so you would have to modify the sources. You would have to rebuild the container and restart it. You know what I did when I stopped it and started it again? You would have to do it in Java. In Node, it's a little bit better. Little bit. Yeah.
Hi. In your example, you had a Docker Compose file and then 3 subdirectories for the microservices. How does it change if, like, say, each of those microservices is a separate repository, and let's say you have like 20 of them? Do you put the Docker Compose file in another repository and then put them in the file system in a certain way? Or?
Yeah. I'd say it depends. For a small project, you would have the compose file along all the services. Some of the services would just pull images from the hub. And if you have a bigger project, maybe you can use like Git submodules for each of the service. But usually you see the compose file and the services in the same folder.
Okay, thank you.
In your example, you showed that words-java name for the DNS round robining, and I'm curious who's responsible for resolving that. Like, where does that get resolved?
So
is that available? Like, if you just say host on the command line or dig on the command line, will that work there? Like, will you see those IPs, or is that not visible to the host OS?
I'm not sure I understood the question, but so on your single node swarm or multiple node swarm, there's a DNS service running that is in charge of mapping the name of the services to IP addresses. So the code that's running inside containers, if it does like a standard name lookup, it will get the IP address of a container. And if it's IP addresses, it will get one round-robin random, right? So
Yeah, I was asking about, in the code, you showed that example with the words -java name
Yeah.
in the Java service.
Yes.
Like, who's responsible for resolving that? Because that was before you even did the swarm init.
Yeah, so it's really the DNS server that's running inside the engine that does that. So what I do in my Java code, I just write words-java, and I just point to the port that this container should bind on. And in fact, the engine will do the magic of resolving the name to the IP, and will do the magic of resolving the port to the actual port it's running on. So it's really taken care by the engine. You don't have to think about it. And it's what makes the microservices very easy to aggregate. You can compose an application based on lots of microservices that didn't know they should work together, right? If you take a look at the sources, you will see that the words dispatcher, which is written in Go, and the words Java, which is written in Java, they both serve the same REST API. And it's just by changing the name of the service that I can have another service pointing to one or the other. I can just switch them, and I don't have to change a single line of my code to do that. It's just the compose file that I can give names to my services. Does it answer the question? Yes. Thanks.
So as a developer, I'm already using Docker Compose to define my project's infrastructure needs. What is the point, what is the benefit in switching to these bundles of services? I'm not sure I'm getting the difference and the benefit.
Sorry, I'm French, sometimes I don't understand.
So what is the difference or the point in switching from Docker Compose, the YAML definition, to the bundles or services definition?
Sorry. It's really, so as you've seen, there's really one action to go from one to the other. But then the compose file, if you take a look at the compose file, I'm going to open it. It doesn't say which specific version of the web of this one or this one I should use. It's really a developer tool. You know, I'm composing an application based on microservices, and those microservices, along the day, they will change version. I will change one, another one, I will commit, I will push it, pull it, and then what I want to put in production is not my laptop, right? I want to put a specific version of each image. And it makes it very easy to do that. Before that, we would just tag all the images, we would change the compose file, and then we would say, okay, take this compose file, it will pull the images. You don't have to do that anymore. You just create a bundle, it identifies this very specific version of each service, and you can put them in production, as you've seen this morning. So I think it's really making the gap smaller between the dev and the ops. But the dev will use Compose, and the ops doesn't really care about Compose.
And where do I push this bundle? Will Docker Hub handle bundles as well, or is it like? For
now, you have to share it on a USB key, as you said this morning. Now you have to send it. You have to share it how you want. Maybe you'll be able to do it differently, but for now, it's just a JSON file. You can just.
So it's a way to create a tarball of the infrastructure and code that I'm using for my project to send it somewhere.
Of all the images and the bundle file? No, I don't think so, but I'm pretty sure there's a couple of things that are going to solve that problem.
Okay, thank you.
Hi.
Last question.
Two small questions, hopefully. One is, in your example, you created this stack and saved the services. I was just curious where that's saved. Is that saved on the file system by the Docker engine? Like, what is doing the caching so that when you restarted your laptop, it knew to start those services, that stack?
Sorry?
What is saving the stack when you created your services so that when you restarted your laptop?
Yeah, so it's using 112 features. When I deployed the bundle, it created services. The services, they are persistent. So they are stored next to the Docker engine. And when the Docker engine and Containerd are started, they will pick up that, and they will recreate the services, and they will try to reconciliate the state, the actual state, to the state we ask it to make work, to well, whatever.
Yeah, and second small question is the bundle supported to push to private registry? Because I noticed in your
I don't
example you
know.
pushed up to the Docker.
I don't know. You should go ask the engine guys. I don't know. I'm pretty sure yes, but I don't know.
Thank you.
Thank you very much.